The National Electrical Code, or NEC, does not specifically address the replacement of electrical metallic tubing, also known as EMT conduit, that has been exposed to carbonization. However, industry best practices recommend replacing EMT conduit that has been exposed to severe carbonization, even if the conduit's integrity appears to be intact. Carbonization can weaken the conduit, making it susceptible to damage or failure in the future. It is important to consider several factors when evaluating carbonized EMT. Firstly, the severity of the carbonization should be assessed. Severe carbonization may have compromised the conduit's structural integrity. Secondly, the location of the carbonization is important. Carbonization located near connection points or bends can be more critical, as it can weaken the conduit at these vulnerable areas. Thirdly, the type of EMT matters. Lighter gauge EMT may be more susceptible to damage from carbonization than heavier gauge EMT. Lastly, accessibility is a consideration. If replacing the conduit would be difficult or costly, it may be necessary to consult with an inspector for guidance. Based on these factors, it is generally recommended to replace EMT conduit that has been exposed to severe carbonization. However, if the carbonization is minimal and the conduit's integrity is not compromised, cleaning the conduit and ensuring proper connections may be sufficient. While the NEC does not require the replacement of carbonized EMT conduit in all cases, industry best practices and safety concerns should guide the decision. If there are any doubts about the integrity of the conduit, it is always advisable to replace it. Electrical metallic tubing, or EMT, is a common raceway solution used in electrical installations, mainly for its cost-effectiveness and ease of installation in exposed locations. However, its performance and safety can be compromised when exposed to events like electrical arcing or short circuits, leading to carbonization. Carbonization occurs when the EMT is subjected to high temperatures, typically from electrical faults, which causes the metal to undergo a chemical change, leaving a black carbon residue on its surface and potentially altering its internal structure. The primary concern with carbonized EMT is the potential reduction in its structural integrity and protective capabilities. The heat generated during an electrical fault can weaken the metal, making it more susceptible to bending, cracking, or collapsing under physical stress or environmental factors. This is particularly concerning in areas where the conduit is responsible for protecting conductors from physical damage. Another critical concern is the reduction in the conduit's ability to provide a safe grounding path. EMT is often used as an equipment grounding conductor, providing a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. When EMT is carbonized, the conductivity of the metal can be reduced, increasing the impedance of the grounding path. This can delay or prevent the proper operation of protective devices during a fault, increasing the risk of electrical shock or fire. Industry best practices typically dictate a conservative approach to dealing with carbonized EMT. Given the uncertainties about the extent of damage and the potential for future failure, the general recommendation is to replace any EMT that shows signs of significant carbonization. This is especially true if the carbonization is located near joints, bends, or supports, where the conduit is already under mechanical stress. When assessing whether to replace carbonized EMT, several factors should be considered. Firstly, the severity and extent of carbonization must be evaluated. Surface carbonization may be less concerning than deep, penetrating carbonization that affects the conduit's wall thickness. The presence of cracks, deformations, or other signs of physical damage should also be taken into account. Secondly, the location of the carbonization is important. Carbonization near joints or fittings is more critical because these are points of mechanical and electrical connection. Damage in these areas can compromise the integrity of the entire system. Thirdly, the type and size of EMT should be considered. Thinner-walled EMT may be more susceptible to damage from carbonization than thicker-walled EMT. Similarly, larger diameter conduits may be able to withstand more damage than smaller diameter conduits. Fourthly, the environmental conditions where the EMT is installed play a role. EMT in damp or corrosive environments is more likely to experience accelerated degradation after being carbonized. When replacement is deemed necessary, it's crucial to follow proper procedures to ensure the safety and reliability of the electrical system. This includes energizing the affected circuits, using appropriate personal protective equipment, and carefully removing and replacing the damaged EMT. The new EMT should be properly sized, supported, and connected to maintain the integrity of the raceway system. In situations where replacement is not feasible or practical, and the carbonization is minimal, the EMT may be cleaned and inspected for damage. The carbon residue can be removed using a wire brush or other abrasive tools, and the conduit can be visually inspected for cracks, deformations, or other signs of damage. However, this approach should only be taken if the conduit structural integrity is not compromised and the grounding path remains intact. In all cases, it is advisable to consult with a qualified electrical inspector or engineer to determine the appropriate course of action. They can provide expert guidance based on the specific circumstances and applicable codes and standards. They can also perform tests to verify the integrity of the grounding path and the overall safety of the electrical system. In addition to the physical and electrical considerations, it's important to address the underlying cause of the carbonization. Electrical faults are often the result of improper wiring, damaged insulation, or overloaded circuits. Correcting these issues is essential to prevent future incidents and ensure the long-term reliability of the electrical system. This may involve rewiring circuits, replacing damaged components, or upgrading the electrical service to meet the demands of the load. The decision to replace or repair carbonized EMT involves careful consideration of multiple factors, including the severity of the carbonization, the location of the damage, the type and size of EMT, and the environmental conditions. While the NEC does not provide specific guidance on this issue, industry best practices and a conservative approach to safety should guide the decision-making process. Consulting with qualified professionals and addressing the underlying causes of electrical faults are essential steps in ensuring the safety and reliability of electrical systems. The National Electrical Code, or NEC, serves as the cornerstone for electrical safety in the United States. However, it's important to recognize that the NEC is not a design manual or a substitute for engineering judgment. It provides minimum requirements for electrical installations, and compliance with these requirements does not guarantee a completely safe or reliable system. In the context of carbonized EMT, the NEC does not offer specific guidance on when replacement is required. This is because the decision depends on a variety of factors that are difficult to codify in a prescriptive manner. Instead, the NEC relies on the judgment of qualified electrical professionals to assess the situation and make informed decisions based on their knowledge and experience. One relevant section of the NEC is Article 110.3, Examination, Identification, Installation, and Use of Equipment. This section requires that electrical equipment be installed and used in accordance with its listing and labeling instructions. If the manufacturer of the EMT provides specific recommendations regarding the handling of damaged or carbonized conduit, those recommendations should be followed. Another relevant section is Article 250, Grounding and Bonding. This article provides detailed requirements for grounding electrical systems and equipment to ensure electrical safety. As mentioned earlier, EMT is often used as an equipment grounding conductor, and its integrity is crucial for providing a safe grounding path. If carbonization has compromised the conductivity of the EMT, it may be necessary to replace it to comply with the requirements of Article 250. Additionally, the NEC contains requirements for raceways in general, which may be applicable to EMT. For example, Article 300.12, Mechanical Continuity a circumflex raceways and cables, requires that raceways be installed as a complete system and be mechanically secured to prevent damage. If carbonization has weakened the EMT to the point where it is no longer mechanically secure, it may need to be replaced. While the NEC does not provide specific guidance on carbonized EMT, it does establish a framework for electrical safety that emphasizes the importance of qualified professionals, proper installation practices, and adherence to manufacturer's instructions. When dealing with carbonized EMT, it's essential to consider the relevant provisions of the NEC and to exercise sound engineering judgment to ensure the safety and reliability of the electrical system. In addition to the NEC, other codes and standards may be relevant to the assessment and replacement of carbonized EMT. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment, including EMT. These standards may provide guidance on the proper handling and installation of EMT, as well as recommendations for dealing with damaged or deteriorated conduit. The International Association of Electrical Inspectors, or IE, is another organization that provides valuable resources for electrical professionals. The IE publishes articles, guides, and training materials on a wide range of electrical topics, including raceway systems and grounding. Consulting these resources can help electrical professionals stay up to date on the latest best practices and code interpretations. Local codes and regulations may also impose additional requirements for electrical installations. It's important to check with the local electrical inspector to determine if there are any specific rules or guidelines that apply to carbonized EMT in your area. The electrical industry is constantly evolving, with new technologies, materials, and installation methods being developed all the time. Staying informed about these developments is essential for electrical professionals who want to provide the highest level of safety and service to their customers. One way to stay informed is to attend industry conferences and trade shows. These events provide opportunities to learn about new products and technologies, network with other professionals, and earn continuing education credits. Another way to stay informed is to subscribe to industry publications and online resources. These publications provide timely information on code changes, new products, and best practices. In the context of carbonized EMT, it's important to stay up to date on the latest research and recommendations regarding the effects of heat and electrical faults on raceway systems. This knowledge can help electrical professionals make informed decisions about when to replace or repair carbonized EMT. Dealing with carbonized EMT requires a combination of technical knowledge, practical experience, and a commitment to safety. By staying informed about the latest codes, standards, and best practices, electrical professionals can ensure that electrical systems are installed and maintained in a safe and reliable manner. When faced with the decision of whether to replace carbonized EMT, it is important to adopt a systematic approach that considers all relevant factors. This approach should include the following steps. Firstly, perform a thorough visual inspection of the EMT. Look for signs of carbonization, cracking, deformation, or other damage. Pay close attention to areas near joints, bends, and supports, as these are often the most vulnerable. Secondly, assess the severity and extent of the carbonization. Determine how deeply the carbonization has penetrated into the metal and whether it has compromised the conduit's structural integrity. Thirdly, evaluate the location of the carbonization. Consider whether the carbonization is located in a critical area, such as near a connection point, or in a location where the conduit is exposed to physical stress. Fourthly, determine the type and size of the EMT. Consider whether the EMT is made of steel or aluminum and whether it is a standard or heavy-duty type. Also, consider the diameter and wall thickness of the conduit. Fifthly, assess the environmental conditions. Consider whether the EMT is exposed to moisture, corrosive chemicals, or extreme temperatures. These factors can accelerate the degradation of carbonized EMT. Sixthly, consult with a qualified electrical inspector or engineer. Obtain expert guidance on whether replacement is necessary and what steps should be taken to ensure the safety and reliability of the electrical system. Seventhly, document all findings and decisions. Keep a record of the visual inspection, the assessment of carbonization, the evaluation of location, the determination of EMT type and size, the assessment of environmental conditions, the consultation with experts, and the final decision regarding replacement. This documentation can be helpful for future reference and for demonstrating compliance with codes and standards. If replacement is deemed necessary, follow proper procedures to ensure a safe and reliable installation. This includes de-energizing the affected circuits, using appropriate personal protective equipment, carefully removing the damaged EMT, installing new EMT of the same type and size, properly supporting and securing the new EMT, and testing the grounding path to verify its integrity. If replacement is not deemed necessary, clean the carbonized area with a wire brush or other abrasive tool to remove loose carbon residue. Then inspect the EMT for any signs of cracking or deformation. If any damage is found, replace the EMT. If no damage is found, monitor the area for any signs of future degradation. In all cases, it is important to address the underlying cause of the carbonization. Electrical faults are often the result of improper wiring, damaged insulation, or overloaded circuits. Correcting these issues is essential to prevent future incidents and ensure the long-term reliability of the electrical system. By following a systematic approach and considering all relevant factors, electrical professionals can make informed decisions about whether to replace carbonized EMT and ensure the safety and reliability of electrical systems.